Hello everyone, Mr. John from Areteem Institute here with this week's Thursday Tidbit, continuing to cover some AMC 10 and 12 problems. We are now 2 weeks away from the A exam date. Be sure to check out our blog for some tips and prep. I want to give a quick shout out to the Zoom International Math League, the ZIML site. That's a great place that you can do some practice mocks, some practice problems as you're in the final preparations before the test day. Now let's jump right into the problems. We have two number 21s today. Neither of these are going to be too bad as long as you work through them step by step here. So first question, right, want to go through some keywords as we're reading it. So we have positive integers A and B. So that's something we'll need to keep track of later, right? And this is such that these graphs intersect the x-axis at the same point. What's the sum of all the possible x coordinates at the end, right? So we'll need to keep that in mind. But just to start, positive integers A and B, that will come into play a little bit later. But to get started, let's focus on the fact that we're thinking about the intersection points of these lines and the x-axis. So, like I said, step by step, x-axis is when y equals 0. So if we just start looking at this here, we have 0 is ax plus 5. Pretty simple linear equation here, right? So if we subtract 5, divide by a on both sides there, right? We have that x is negative 5 divided by a. That is our first line. Normally here I'd be saying, okay, a is not 0, we have to worry about that, but we have positive integers, so that's not a problem here. So second line, 0 equals 3x plus b. This intersection point then with the x-axis, subtract b, divide by 3. X is negative b divided by 3 in this case. Now, our key piece of information for solving this problem is that these need to then be the same point there. So of course, this is then a hint to set these equal. So we have negative 5 over a equals negative b over 3. And so cross multiplying, negatives cancel out on both sides. We have a times b is equal to 15 here. Now, right, when we think of this, now our positive integers a and b come into play, right? So if we have a and b multiplied together equals 15 there, right? We are then thinking about pairs of numbers, positive integers, that multiply out to 15. So this is not too bad to list out. We can list them as ordered pairs here. Note the order does matter in this case, so we want to kind of be careful how we're writing this out. Of course, 1 times 15, we're then also going to have 15 times 1. But you'll see what I mean where the order kind of matters in our x value there. So we do want to keep track of these in order. Luckily, 15 isn't that big of a number. I just want to mention that the procedure is not going to change even if we have a larger number, right? So you might say, well, what if we had like a times b is 35 or 45? The question is going to be a lot more annoying, but it's not going to really be any harder in that case. So let's do kind of this fairly quickly here. One by one, right? Let's do this verbally. This is giving us x values here. Just to double check, Okay, if a is 1, we have negative 5 divided by 1, that is negative 5. Checking with the b, negative 15 divided by 3 is also negative 5. Do you really need to do this for all of them? No, but I just want to point out if you kind of want to check one of them, maybe that's helpful just to make sure we didn't make any mistakes or anything there. But if we're listing all of these values out here, we have negative 5, negative 5/3, negative 1, negative 1/3. Now, reading our question, sum of all possible x coordinates here. So at the end, right, really quickly, not too much work here to say, but I'll point out that negative 5/3, negative 1/3, that's negative 2. So negative 5 plus negative 1 plus negative 2, we have negative 8 is our sum. So this gives us answer choice E in this scenario. So like I mentioned, not too difficult of a problem, but one that it's good to just work through step by step. And when you're reviewing these things, I would recommend asking yourself, okay, well, what if these numbers were different than 5 and 3, right? What if we had a different number than 15? What are some different scenarios? Where would this method work? Where would it fail? That can help you when you have similar questions or different questions come up on the actual test date there. Okay, let's look at our AMC 12 problem here. This one definitely a little bit more difficult. Definitely involves some logs. We have this greatest integer function here that we need to deal with a little bit in that case as well. But, right, again, if you take some natural steps, you can break this down and kind of work through things in a nice way here. Now, one thing that I want to mention right off the bat is when we have this floor function, when we have this x, just as a hint for your brain sometimes, if you need to swap other variables, right? Sometimes these weird symbols are scary to us or kind of make it hard to think clearly about things, especially for floor function stuff, right? The fact that this is an integer is really something we want to take advantage of here. So in this case, let's just right off the bat, I want to replace that floor of x by n. And right, the thing that I want to note here then too is that then this x minus the floor of x, or x minus n portion, right, this is between 0 and 1. This is oftentimes called the fractional part, but let's not kind of mess with the notation or anything here as well. But that kind of gives us a picture of what's going on in this case, right? So of course this is, and maybe let me even replace it there just so we have that notation. This x minus n is always between 0 and 1 in that case. Now, what do we know about n, right? Well, since x is between 1 and 2014, including 1, not including 2014, we actually have that n is an integer, right? So n is either 1 or 2 up to 2013. So this is just some bookkeeping. Like I said in the previous problem, we want to stay organized and work things out nicely in this case. Okay, so let's get started then there. So we have this function floor of x times 2014 to the x minus floor of x in the exponent minus 1, things like that there. taking it step by step, we are looking for the places where f of x is less than or equal to 1. Now, keeping in mind, I'm saying floor of x is n. We know n is an integer ranging between 1 and 2013. Of course, if the floor of x is n, that's telling us the range of x values that we have there. I'll come back to that in a second. But let's write out everything then in terms of x and n. So our function f of x, this becomes n times 2014 raised to the, in the exponent, just for clarity, let me put parentheses, x minus n minus 1. And we want this to be less than or equal to 1 in this case. Now, as I mentioned, x and n are related, things like that, but let's solve this as an inequality for x, right? This is where that kind of replacing it with n, think of that as something fixed for a moment. So we divide by n, we add 1 to both sides. So we have something like 2014, whoops, no exponents yet, 2014 raised to the x minus n. This is less than or equal to 1 over n plus 1. And just to save some time verbally, right, that is here, let me rewrite that right away. Here with a single denominator, this is 1 plus n divided by n. Now, why am I doing that there? Because if we write this then with logs, we take log of 2014, or sorry, log base 2014 on both sides. We get rid of that 2014. X minus n is less than or equal to log base 2014 of, and let me just write n plus 1 over n in this scenario. So if we write this one last time, x is less than or equal to n plus this log base 2014 of n plus 1 over n there. But remember that if the absolute value of x is n, right? What is that really telling us? So what do these intervals look like? What are our intervals looking like here, right? So if we think about the intervals and the sum of the intervals, well, if we're thinking about this for the given n values, so if the floor of x is n, that means that our lower bound for these intervals is n. X has to be less than or equal to n, which is less than or equal to, right? We then have n plus log base 2014 times n plus 1 over n. And the values of n, right, are ranging in those values that we kind of were talking about before. So n is in that range we have there. Now, n up to n plus this, right, the sum of the lengths of these intervals then, and let me use summation notation here just to save some room. If you need to write this out, write it out piece by piece. There's no shame in doing that. But here we have this sum, so each interval is of length log base 2014 of n plus 1 over n. So, right, we have log of 2014 2 over 1 plus log of 2014 3 over 2, etc. But this is a very important log rule then, right? If you have the sum of a bunch of logs, this is the log of the product of all of those things. And let me write this out without summation notation. So we have all of those logs added up. We can combine all of those logs into a product. So when n is 1, we have 2 over 1. When n is 2, we have 3 over 2. Dot, 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 right? All the way up to when n is 2013, right? We have 2014 over 2013 in this case. But wait a second. The 2's will cancel, right? The next term, 4 over 3, the 3's cancel. All the way up to the 2013 cancels there. So what we have in this scenario is just log base 2014 of 2014 is equal to 1 there. So pretty easily then our final answer simplifies maybe surprisingly nicely, and the sum of the lengths of all of these intervals is 1. Again, don't get too overwhelmed, right? When you first look at this, or when I first look at this even, it looks pretty messy. But if you just start exploring it, okay, let's say, what if the floor of x is some integer? What range are we talking about there? Everything starts to fall into place, and you have a nice final answer once we use some rules of logs at the end. That will do it then for today's video. Thank you for watching. If you have ideas for other solutions, problem requests, idea requests for the future, let us know in the comments below. Subscribe to our channel for all of these videos. Check out the archive as well. Otherwise, I hope to see everyone again next week. Thanks for watching. Goodbye.